We mean by expert system? These are artificial intelligence computer systems that do what? That do what? Emulate human experts in decision making. Emulate human expert in decision making. For example, typical example, you go to a hospital, so you sit in front of a doctor, and then the doctor will keep asking you question, what's wrong with you? And then you'll tell the doctor your symptoms. I have a headache, for example. And then the doctor says, and what else? High fever. The brain of the doctor now is working, connecting the headache with the fever. And then they might ask you to minimize the possibility, do you throw up? If you say yes, they know the disease. If you say no, they know another disease. So this is an expert working. This is an expert working. So what they do normally, they ask you a question. They ask you to make test. They see the result of the test. Sometimes, whenever you show them the result of the test, they will say, okay, you have the following. This is their diagnosing. This is the following disease. You take these pills and you are okay. Sometimes they are not accurate. They're not 100% sure. They will ask you to do extra test. Why? To minimize the possibilities, to make sure. The same goes if we take the experience of these doctors and ask them for each and every symptoms and each and every disease, and we put all this information in a database. And then we allow junior doctors, yes, young doctors, to ask this system, and the system will recommend, the system will advise, the system will solve the problem. Why we do this? We can gather experience and knowledge of hundreds of doctors and put it in a tiny system that can be now used in each and every hospital. So it will be less expensive than hiring an expert doctor, because expert means money, expense. So nowadays in the school, this system works. For example, whenever they take your, for example, sample of your blood, previously doctors will be looking using a microscope for your samples of blood, one by one. Nowadays, what they do? They put it in a machine, isn't it? And then they sit there and they chat. The machine will be rotating, testing, and then the machine will provide a report. They will give you the report. The doctor will look at the report. This machine is taking the experience from real doctors back in the days, and it's always updated. It's faster, cheaper in the long run, better than having doctors and microscopes looking at each and every sample manually, isn't it? So these are expert systems that you can inquire, you can query, you can ask. They provide solution, advices, or recommendation based on their knowledge. Example, if you play online chess, you are playing against the computer. For the ones who are playing online games, normally you play against the computer. For online chess, for example, if you play beginner mode, that means the knowledge base of the computer that will be used is less than 25%. So whenever you make a move, the computer will try and predict your next two moves. Okay? You can beat the computer easily. What if you raise the level into intermediate? The knowledge base will be raised for 50%. The computer can now detect your next 10 moves, which is will be harder to break. What if you are hard mode or expert mode? It will use 100% of all the experience of every brilliant expert chess player. Then whenever you make a move, they will try and predict your next 100 different possibilities of moves. So it will find it very hard to beat. Even number one in chess couldn't beat the computer back in the days, 10 years ago or 5 years ago. Yes, number one in the world tries to beat the computer in hard mode, and the computer, in seconds, he crushed it. Why? Because the computer can think, if you move like this, that means you might do next or all possible in fraction of a second. Are we good? So expert systems are the future of all systems that you would like to ask questions, and they provide recommendation, advices, or solutions. Example, you will find it in, for example, for digging, for mining, petrol mining, gold mining, this kind of expert system nowadays, with help of devices, they will show you whether you can dig here, whether you will find oil here, whether you need to go in another place. You just input the information and the system will guide you what to do. So example, you need to remember them of these systems are the following: mineral prospecting, strategy games like chess game. Straight, please. Next, car diagnosing. Nowadays, for the cars, the Mercedes and the BMW cars, whenever you go to fix the car, they will plug in a small computer. The computer will check each and every sensor in the car, and everything that are abnormal, it will show you that this piece or this part has to be replaced, better than manually looking for it. The high expensive car, they have more sensors, so it's easy to use this expert system to detect what's wrong with the car or how to fix the car. Are we good? And other application that you will find over there. So advantages of this system. Look, what are the advantages? No emotions, and this is a problem of humans. Systems they never produce any kind of a solution based on emotion. They're straight to the topic. You get it? Which is a plus in certain conditions, yes, and bad in other certain conditions. The second thing, they have high accuracy, because whenever the system is built using large database, that means the system will produce better and more accurate solutions or recommendations. Yes, so high accuracy, fast response time, unbiased reporting. Get to the point. Unbiased reporting. Disadvantages: the setup and the maintenance of this system, and the output of this system depends on the knowledge inserted. So if a few knowledge is inserted, that means this system will produce less accurate results. And whenever you find that very accurate system, that means this system has been built for years and they're very expensive. So whenever they are used in schools or in other factories, you will find that they will have to pay subscriptions, annual subscriptions. Every year they have to pay to two things, because they are using the system and to get updates, which is very important. And that's why these systems sometimes are better. For example, in let's say in medical or in hospitals, sometimes they prefer it more than doctors. Why? They are always updated. You might have a doctor that is not always updated, old-fashioned one. Okay, so sometimes they need to go back into these systems, because these systems might bring new diseases, new symptoms, new diagnosing into the field. Very good. The question will be how you can construct this system, and these are the part that you need to memorize: user interface, inference engine, knowledge base, rule base, explanation system. These are the part of any expert system. You need to memorize them. They will ask you how we can construct an expert system, or they will ask you define the following parts of the expert system, or mention the parts of the expert system. So these boxes are very important. Now let's look what we need to construct an expert system. Expert, first of all, we bring a couple of experts. What we do with them? We gather the information, we put it in a database. What we call it? Knowledge base. So the first important part of an expert system is a database of knowledge, or what we call it, the knowledge base. And then using the knowledge base, I will set some rules, which is here called rule base. Please draw it there. Draw it in your notes. Draw a small box there. Rule base. Sometimes rule base is part of the knowledge base. That's why in this diagram, sometimes you won't have it differently, but it's better always to put it as a separate box. Yes? So why we have rule base? Because the knowledge has to be separated and divided by rules. Certain diseases have rules. If there is a fever, whenever you sit in front of a doctor, for example, and you say you have a fever, half of the diseases will be eliminated by the doctor. All the diseases that does not require fever will be eliminated without the doctor said. These are rules. Are we good? So you need a rule base to be connected with the knowledge base. And then what do you need? You need a user interface. Meaning the doctor has to sit in front of the computer like this one. Let me show you. Like this one. This is the user interface. It will ask you to insert what? To insert some kind of answers. Yes, you need to. Sorry, there عندي مشكلة. Ask you questions and then you need to insert answers. Answer question, and then you run the system, and then the output of the system will come. This is what we call a user interface. And normally, whenever you have a user interface, put in mind, whenever we have a user interface, normally it will contain questions that can be answered by yes or no with no other details, because details are hard to find in the database, isn't it? Text. That's why computer prefer for logical answers, always prefer yes or no, true or false. For these kind of input systems, always will be answered by yes or no, true or false. So now what we have, a knowledge base, a rule base, and a user interface, so a normal person can ask the system questions, and based on the answers of that person, the system might recommend or advise. Now, how the knowledge base will be searched? How the knowledge base will be searched to find answer? By using an inference engine. Now, why they didn't just call it a search engine? Why they call it an inference engine? لأنه searching here will be searching with logic. So the inference engine is a search engine that processes before finding the results. If you look at the box down there, you will find that inference engine is where is it? Is the main processing element. This is the problem solving part. This is the brain of the system. That's why we call it inference engine. It's not a normal search engine, because whenever it searches the knowledge base, it will search based on the rule base, isn't it? It will search wisely. Very good. So whenever they ask you for the part are knowledge base, rule base, inference engine, the brain, a user interface. Never say search engine, they will give it to you wrong. And last but not least, explanation part. Explanation meaning, after the system provide you with the advice or recommendation, the system will give you an explanation why they have reached that conclusion. Because you need to know. Whenever the system says no, do the following, they need to explain why should I do the following. And this is what we call explanation. Yes, system. Are we good?
Yes.
Yes, so far?
Yes.
Typical questions. Pay attention, please. Typical question, or how we create an expert system. So the steps needed for creating such a system. What we say, first thing what we need to do, we need to have what called a knowledge base. We need to collect information from expert. Whenever we collect information from expert, we create what we call a knowledge base. And then searching the knowledge base later will not be randomly. You need to set some rules. That's why the second one is designing the rules base based on the knowledge base. You have to set some kind of conditions and rules to find the searching will be faster and more accurate. And then what we need, a user interface need to be created to do what? So you can inquire the system, you can ask questions and answer questions, so the system can provide you with a recommendation or advice or solutions. And then we have the inference engine, and we said that the inference engine will be used for searching the knowledge base using the rule base. Yes, inference engine will be searching the knowledge base using the rule base. That's why we say this is the brain of the system. And last but not least, the system will have to be tested. And how you can test the system? You can test the system by using actual data, meaning you know the results. We have done it outside the system. We have concluded the following results. We now test the system and we should get accurate or the same match in the results. If we are getting the same match in the result in different situations, that means the system is 100% working good. Examples you will find in the past papers. One of the example is medical diagnosing. Yes, and in medical diagnosing you will find that these are the steps. First of all, what you do, you have a user interface, what we call it, interactive screen. You will ask questions and you will answer this question using a keyboard or a touch screen. And we mentioned most of these questions should be logical questions. Yes slash no. What will happen? Inference engine will be looking for answers in the knowledge base using the rule base. If they found matches, it's done. Otherwise, sometimes if the inference engine find that there are more than one possibility, what will happen? Extra questions might be asked by the system to narrow down the possibility. Once it's done, what will happen? The system will suggest the illness for you, and then an explanation system will show you why the system has concluded this conclusion. Very good. So expert system is a huge topic in this chapter. They might ask you what we mean by it. They might ask you how to create it. They might give you an example and ask you to mention the steps needed by an average person to query the expert system and get some sort of results. Are we good? Next,